Hey, I'm Marcia, and I'm here to talk about serverless. Not about Ruby. I don't have zero experience with Ruby, so don't ask me Ruby questions. So I'm here today to talk a little bit about the story about our migration to serverless from a traditional server architecture. But first, I will give you a brief introduction on serverless because this is not a serverless meetup, so I want to put everybody on the same page. I would like to know how many of you have heard about serverless. Can you raise your hands? Oh, good. How many of you have some production code running on some serverless instance? Good. So a couple, very few. Good. So I have a good introduction. So I am Marcia. I work at Rovio, the creators of Angry Birds. I came all the way from Finland, and I've been working there for almost 5 years. I'm an Amazon community hero, so I do a lot of free stuff for Amazon. That's what it means. And also, I'm a serverless champion. I have a YouTube channel. If you want to learn about serverless there, you can find a lot of free content that you can, mostly with JavaScript, sorry. And I'm very active in Twitter, so you can follow me there as well. So let's start with serverless and what it is. Serverless is two things, and that's what it makes it a little bit confusing. Everybody thinks that it's just functions as a service, that's what it makes it popular and when the name comes through. But backend as a service is something that we were using forever, and I'm pretty sure that only 2 raised hands because they are using lambdas or some kind of functions as a service, but I'm pretty sure all of you have used backend as a service. What is backend as a service? Backend as a service is like software as a service, but it's transparent. It's connected through an API to your backend. So your users don't know that you are using kind of S3 storage from, for example, if you're storing your static files in Amazon, or if you are using MongoDB database, like the hosted version by Mongo. Your customers don't know that, so you're just connecting an API. Or if you're using the authentication flow from Auth0 or other authentication flow, that's backend as a service. So you pay as much as you use, and you connect it through an API. And that's something, in one way or another, we have been used to use a lot. So I will not go into backend as a service. I will talk about functions as a service. That is what it brings the name to serverless, and that's what makes serverless popular. So let's talk about the traditional server architecture. We have this kind of very simple drawing. It looks very big here. And that's the host. The host can be any computer in your basement, a computer in your cloud, a container, virtual machine, a real computer. Anything can be a host. And there you put your application. It's running all the time. And it has some functions of things that you want your application to do. So the application is all the time on. So imagine that your host can take only 100 requests per second. So even if you have 1 request at a time, you need to have that host running. But you have 2 ways to scale up your host. You can either go faster, make a bigger, expensive machine, or then you can go horizontally and have multiple hosts and scale up. Many of the public clouds have now the ability to have some kind of rules to scale up. So you can put that, but still, you're still over-provisioning because if you have 101 requests, you might need 2 hosts. So you're still provisioning 99 extra capacity. So that's one problem with the traditional server architecture. You're always over-provisioning or under-provisioning if you don't have rules in the place. So imagine your application go viral one day and your rule says that you only want to have maximum 3 hosts, and then you will be throwing out all the customers that you are getting. So that's one big problem with the traditional server architecture. The other problem, in my opinion, is when you want to change function free. You need to deploy the whole application, you need to test the whole application, and then you have to have rules on how to, if you have multiple nodes, how to make that change around the different nodes. So, okay, we change 1 node at a time, or we change all the nodes and we are unavailable for a while. You all have faced that problem, that how we put that new build out. So serverless solves some of those issues. And it brings new others, so nothing is perfect. So in the case of serverless, you will be having a function service platform. And that will be hosted in some cloud in general. You can host that platform yourself, but that's kind of not very smart, I would say, because you will be out of the way of serverless, but you can do that as well. There is host your own serverless thing. But for example, if you use AWS, Azure, Google, IBM, even smaller providers will provide a function service platform. And what you do there, you grab your code and you throw it into the platform. And the code is totally idle. It's just sitting there, waiting for a request. A request can be anything. It can be an HTTP request. It can be a message in a queue. It can be, I don't know, a file that changed in your file system. It can be a line in a registry in a database that changed. So events, requests can be anything. And that will wake up a virtual container. So the platform will create a virtual container and will deploy that function that was requested. The function will respond to the request, and then the virtual container will be killed. There is some efficiency rules. Most of the platform has some rules on how to kill these containers, but in the theoretical way, the container is killed after each of these calls. So if you have 1,000 requests, you will have 1,000 virtual containers in parallel. If you have 1,001, you will have 1,001 parallel virtual containers. So you're always provisioning the right amount of containers. You are not under in provisioning, you are not over in provisioning. You are always in the right amount. And if you want to deploy function free, the only thing you do, you want to deploy a new version, you just push your new code to the function service platform, and then whenever a new virtual container spawn, the new code will go into. So you don't have to think, okay, how I will do the change. And usually these functions are short-lived, so they last, for example, in Amazon is 5 minutes. So for 5 minutes, you might have the old version running because the old ones will keep on running, but as soon as new request comes after your code is deployed, then you will have the new code running. So it's pretty simple. So here are some characteristics and benefits of serverless as a whole, not only functions as a service, but also backend as a service. So it scales automatically, as I said, scales up and scales down, and you're always provisioning the right amount. You have to be careful because nothing is infinite. You always have service agreement. That's good for your wallet because if somebody is hacking you, you don't want to spawn 1 million lambdas. So all the clouds have some kind of service agreement on how many lambdas. For example, lambda is the serverless from AWS, the compute. You have 1,000 out of the box. You can always call Amazon and say, hey, I will need 1 million, and they will say, well, maybe you will start with 2,000 and see how it goes, but you can always increase it. That's a soft limit. And the same happens with databases and other things. You always have some kind of service agreement that you need to be aware, but in theory, it scales. Then you pay as much as you use, so you don't need to say to Amazon, hey, I want to use Lambda, and Amazon will say, okay, you need to run this 1,000 times per day. If not, we will charge you. No. You only pay for the amount that you use. In the case of Lambda, they have this minimal amount of compute that is 100 milliseconds. But in some cases, it can be quite much because you might have very fast Lambdas. But in general, it's OK. And the same for databases. For example, you pay for the amount of storage and the amount of requests that you make out and in. So every use case has different kind of billing, but it's in parallel of how much you use. So you don't have any upfront cost. You don't need to sign a contract with them and give them $1,000 every month just because you're going to use them. That's not the kind of serverless idea. If they're charging you, it's not serverless. So it's event-driven, as I said. You have to have events to wake up these functions. So functions are not running. They are just sitting there waiting for being triggered. And that happens when you are using an event-driven architecture. You have requests coming in, waking up these functions, and doing things. It forces you, in a way, to build microservices, because you can have monolith functions, but that kind of makes it can be very hard to manage monolith functions. And you also, your backend as a service will be separated from your functions, so you will end up building some kind of microservice, or how we call it in the serverless world, nanoservices, because your functions will be kind of, the more you use serverless, then the more you realize that you want to go through the single responsibility principle, that you want to build your functions as small as possible because they're very easy to test and very fast to deploy. So you will even end in a nanoservice world, but microservice, I think, is kind of the norm. And you have very little administration. In serverless, you don't have access to SSH to any of the backends. You cannot fix, if the MongoDB server is down, you cannot fix it. You need to bear with them until they come up. So it happens now and then that, for example, Amazon S3 was broken, I think, last year, and everybody was like out of the internet. And you cannot do anything. You just wait and pray. So you are kind of tied to them, so you need to trust your provider quite a lot. So don't go to a provider that is not something you trust in. You have some administration in the sense, for example, in Lambdas, you can set up how much memory you want it to run. And in the databases, you can decide, okay, I want to use this much read throughput or write throughput. You have some kind of administration, but very little. Most of the heavy lifting is done by the platform itself. So those are the characteristics. And I hope now we are more or less in the same page. Because I will start with my story. So this was 2 years ago, beginning of the summer. And I was working in this project called Toons TV. That it was like Netflix for cartoons. It was, I'm talking in the past because Robio decided to kill it on the end of the year. So it's something that is dead, but well, I still love it. So I was in that project for 4 years almost. And 2 years ago, we were like sitting with our fellow developers. We were a very small team of 3 backend developers, from which 2 of the developers were not doing backend full-time. So we were like really 2 full-time backend developers, so it was a very small team. And at the beginning of the summer, the management went on holiday, so we have time to do technical dev fixing, yay. So we sit together and we were looking at all the things that we were piling up. Now we don't have any features, let's fix this. And we piled the problems into 2 categories. Mostly that our system was really, really expensive, operational costs were really high, and we were a free service, so we were monetizing on ads, and we were distributing video. So that's very expensive. When you transfer video on the internet, it's like, why you're doing it for free? But well, you need to be very efficient. So our costs were very high, and the other problem is that Robio was switching to, at the beginning of the Robio era, they were doing everything themselves. They have this huge technical department with over 100 people building their own services, and then they realized that that doesn't make sense. So they start using managed services more and more. And our team was using still those old legacy systems because we didn't have time to migrate out. So our problems were piled into these 2 categories. So that was the first thing we did. We think about the problems and create solutions on how to fix it. The operational cost is something we were trying to solve all the time. Every time we were like adding caches here and doing this and that, and nothing fixed it. And we were like, oh my God, how we can fix that? And then when we realized that the only thing to fix those operational costs were to re-architect the whole system, because the way that the system was built was not taking any advantage on the cloud. We were just building this 6 billion views system if we were having a computer in the basement. It was totally not efficient. So we realized that we really need to rewrite the whole system, kind of, in order to fix this operational problem. So we've said, how we rewrite a system that has been there for like 4 years with 3 developers or 2 developers. And we found serverless. Serverless was promising this kind of fast development, and by using as many managed services as we could, then we could remove the legacy problem very fast, and then by taking advantage of the cloud and all the benefits that using the cloud 100% was giving us, we were able to solve the operational cost. So that's what was our hypothesis, that using serverless and as many managed services as we could. So we went with that to our manager, and we said, we can fix this operational cost, we will get a lot of money, give us time, we need 6 months for this. And the manager was like, okay, you have 6 months, but we want results. And we were like, yes, we could do it. But we need to hire someone that knows about serverless. We don't know anything. And the manager was like, okay, you have 1 technical person for 1 day a week. Okay. So we got, by 2 years ago, there was almost nobody that knew about serverless in Finland. There were really few people because serverless was not that popular. So we hired 1 consultant 1 day a week to help us. So we thought that instead of getting him to code and do the project for us, the most efficient thing we could do is to sit with him and try to dig in his brain. So we organized this kind of weekly workshop 4 or 5 hours a week just to sit with him. He will review our code, teach us everything. So at the beginning, it was the beginning of the 6 months, we were just learning the basics of how the cloud works, what are the managed services that we could use, what are the best ways to do it. Then we were moving to serverless, how serverless work, how we can use serverless efficiently. Then we were becoming more experts, so we were able to have really interesting discussion on how to build architectures, and then we were pair programming together. And then those kind of weekly activities became like small panel discussions, because he was also learning from us, because he was a serverless expert, but maybe he had 3 projects that lasted for 1 month before. So it was not that, serverless is a very new thing, so we were all learning from each other. And also that helped a lot for our team, because nobody was the architect of the team. All of us were very empowered and were all in the same page all the time. So we didn't put the responsibility in one person, but the whole team knew what was happening all the time. So for us, training the team was very fundamental to move fast and solve this problem in less than 6 months. So now we know what we were doing, and we have our problems, and now it's time to create proof of concepts, because we didn't know what we were doing by that time. This was maybe 1 month in the whole thing, and we were really little experience of serverless and managed systems and the cloud in general. So we were like, okay, let's build proof of concepts, let's get some practice in, and let's validate that these hypotheses that we created are valid. Because when you go to production, you care about testing, you get about like writing nice maintainable code, and all these kind of things that takes a lot of time. When you're building proof of concepts, you are just sitting in your computer and hacking your way out, and it's fun and it's like empowering, so we all want to do that. So we created 5 or 6 different proof of concepts. These are some examples. So the first example was to remove our legacy authentication, that we were using some old Rovio stuff that nobody was maintaining, so we could not touch it, and it was kind of very annoying in order to move forward in our project, because we have very little changes capabilities in that. So we were starting using Amazon Cognito, that's the authentication and authorization system from AWS. So we built a proof of concept to verify that our clients were able to connect with that, and everything was working like seamlessly. We were able to create tokens and return tokens, and everything was good, so we validate that. Then another thing we wanted to change that was very critical for us is our non-SQL database. We were using some React machine that we were having in Rovio internally, maintained by Rovio, but nobody was maintaining it anymore, so it was all outdated thing, and we needed to migrate from there to something more modern that somebody was maintaining and making sure that it worked. And we started using AWS Dynamo. That's the non-SQL database from Amazon. That is a totally managed service by them, so we didn't need to care about that. So that's good, because when you have 2 backend developers, you need to push as much as you can out from your table. The other 3 examples that I have there, the transcoding, image, and content, that's related to what we were transferring on the internet. So when you have service like Netflix, there are 3 things coming to you. First, the metadata, that is your playlist, your titles, your descriptions, the URLs where to find the images, and the URLs where to find your videos. So that's the other 2 things. You have images and you have videos. And usually when you're transferring video, you want to transfer the right size of video. You don't want to transfer bigger video, because that's very expensive. And you don't want to transfer smaller video, because then that makes the customer angry, because quality sucks. And the same happens with images. You want to transfer the right amount of image for the viewfinder. So we need to create pipelines in order to create an efficient way to send the right size of videos, images, and metadata. And in order to do that, we need to optimize the solution, because that's where the costs were high. Those 3 things that we were sending out, we needed to optimize to take advantage of the cloud. And that's when serverless and the whole public cloud becomes very powerful. In order to do this, we need to understand how the cloud works. So the cloud has 2 main parts. The first part is the data center. So Amazon has like 10 data centers around the world, some in the US, some in Europe, 1 in Africa, 1 in South America, and I think 1 in Oceania. So we were using North Virginia, that is, our customers are in US, so we were using that. But there is Ireland, Frankfurt, soon Sweden, so there's different data centers around the world. And then when you're connecting to the data center, so I'm in Poland, and I was using my service in the old times, so I was connecting to the data center. So my request will go through the ocean, run in the data center, and come back to me. That's expensive in time, and that's expensive in money, because Amazon will charge you for those requests that are coming into the data center and crossing the ocean. You don't want to do that. You want to use the other part of the cloud, that is the edge. The edge is where chip happens, so you want to go there. The edge is where the cache is. And there is over 100 edge locations if you are using AWS. I don't know for other clouds, but I imagine they have a lot. So every major city in the world has an edge location. So if my server, after we migrated, when I make a request from Poland, I will connect to whatever edge location is closer. Let's imagine there is one in Warsaw, I don't know. And then my request will go to the edge location, wherever is located in Warsaw, and come back. Really fast, really cheap. But to do that, Warsaw location needs to get populated with the files, the right files. So you need to build a strategy on how to distribute the files and how to get that located. So for us, the easiest way was just to make the first call expensive, and then after that, all the other customers will get the next calls very cheap. So, but that simple solution comes almost out of the box if you have a good architecture when you're using the cloud. That's called CDN, and different clouds have different names, but that's something, if you take advantage of that, then your cost will go dramatically down, and more if you're streaming video. So now we have a solution that we knew that it worked. We have prototypes, we have problems, we have hypotheses, we have everything. So now it's time to build our production code. And before starting to build our production code, we decided to make sure that everything was automated. Because when you're building production code, we wanted to deploy a lot to production very fast. So we start doing changes very fast and starting changing parts of the service to serverless very rapidly. So when we have something ready, we just remove it and we put it out. So for that, we wanted to have a continuous integration and continuous deployment pipeline in place. So whenever we put something out, we know what was out. Because if the developers deploy from their own computer to the cloud, you don't know if those tests were passing, you don't know what is in the cloud, you don't know anything. Things can go totally wrong. So in this was our pipeline. So basically, whenever somebody pushed to a branch, develop or master in our case, Jenkins will take that change, run the test, and deploy to the right stage. We have 3 stages and 3 different Amazon accounts. You can have 1 Amazon account, that's up to taste, or your use cases. So this was very easy. Whenever we push something to develop, it will go automatically to the development stage. Whenever we put something to master, it will go automatically to the staging. And whenever we were not that brave, we need to press a button to go to production, but it was just 1 click. So it was very easy, and that will take whatever was in stage to production. So you can be very brave and just do it automatically as well. But it's save a lot of investigating. We didn't need to hire a private detective to figure out what was in each stage, because you know what is the commit, and if you have some ticket attached to each commit, then you know exactly what is in all the stages all the time. And the last bit for us that was very critical is to automate your testing. So when you're doing serverless, and I think whenever you're doing microservices in general, you want to deploy many times to production in the day. So maybe 10 times, or I don't know, whatever many times you want. You want to be confident that you can put to production code. And for that, you need to have a testing strategy in place that you can trust. You don't want to go manually and click boxes to make sure that your code is working, because you cannot deploy 10 times if testing takes you 1 hour. So you want to make sure that you have the most important tests in place that are totally automated, that your build machine will run before deploying. And that's what we did. We have unit tests, we have integration tests, that those are very, very critical when you're building serverless, because your functions are really small, but they are connecting to so many different places that if you are not sure that the interaction between your function and the different other places, other services, third-party services, your internal services, custom application, client application, whatever, if you're not sure that that's working when you deploy, then you will need to go manually and test. So integration tests are very important. And if you need some end-to-end tests as well, but those needs to be automated as well. So that was very important for us to go to production. So yeah, we managed, we went to production, we put our thing out, and then a year and a half later, they kill us. But we were very happy. The cost went down, so we were very proud, but not down enough. But, but yeah, but that's not the topic of the talk. But yeah, serverless is not perfect. 2 years ago, it was even less perfect. There was almost no experience around. Nowadays, you can find million blog posts, lots of YouTube videos, lot of talks, lot of tools. But 2 years ago, there was nothing like that. So for us, most of the investigation was just to sit and try things. And that, I think, what makes it that I fall in love with serverless, because I really like hacking things. And by then, there was nothing. So I need to hack my way through it. And that what makes it very special for me. But still, there is a lot of room for improvement. So if you want to start with this, you will find a lot of information, but there's still a lot of open gaps that you can start exploring and having fun. There is a lack of tooling. There is a lack of debugging. It's very hard to debug serverless applications. That makes it very fun when you are trying to find a bug on live code. So you need to go your way around because you cannot run those things in your computer. It doesn't work like that, so a lot of console logs. But there is a lack of a lot of things, so it's still a very interesting area for people that are willing to hit their head against the table and are like little masochists like I am. So yeah, serverless is just a new way of architecting and technology. And it's not like containers that were just a new way of like a new piece of technology. Serverless is a new way of architecting software. So that's what it makes it a little bit different and a little bit special, and that's why you need to go back to some of the concepts that you might have learned in school or reading books that you forgot because you were used to running in your own computer everything and testing it, and you were confident to go out. So I think there will be a lot of place for serverless in the future, and it's growing a lot. I don't think it will replace everything to be serverless because there is use cases for everything. And you need to think if your use case, when you are migrating your services, it's worth to go serverless, because just migrating because a new technology is cooler is not smart. It takes a lot of time and a lot of effort. So think through if your own system is worth to be serverless, and maybe you can go serverless, but don't do it just because. And well, that's me. And if you have any questions, I'm here.
So, thank you, Marcia. If you have, do you want to take questions now or downstairs? Or?
I don't know. If they have questions, I will need this.
If you have any questions, then
you can ask.
Oh, Michał, of course.
Hola. Yeah.
So, finish your presentation. I have a question. What was your biggest problem or struggle when you deployed this application to production, and when you encountered this problem, you said, "Oh, if we did that in monolithic, we wouldn't have this problem." So,
excuse me.
What was the biggest issue, the biggest problem that you wanted to go back to monolithic or something else?
We don't want to go back to monolith. Our biggest problem to go to serverless was the operational cost, that we needed to re-architect the whole application. So if we have a bigger team, maybe we have not go to serverless because we never will learn all this new thing and go through all the pain of learning something new. But for us, with such a small team, it really solved a lot of issues, like by using all these legacy, all these systems, managed systems from the cloud. That really help. And then when you need to build really small functions and then you kind of attach it to something else very fast. So for example, if you have your storage and you put files and then you read them very fast from a function. So the amount of code we needed to write was very, very minimal because the cloud was taking a lot of the heavy lifting for us. So that's why we went with serverless. Maybe if we were 10 persons and we could just re-architect the whole thing doing just coding, we will have gone a different way, but in our solution, we were so small and we could not hire anybody, so that's why we went serverless. And the biggest pain was to learn the whole thing, because I was using the cloud for a long time, but I was never directly connected to the cloud. In Rovio and in other companies, we always have this kind of layer of abstraction for developers when using the cloud, and as we were building servers, we just put things in EC2s or in the containers, so we really never have to be in touch with the cloud. So learning the whole experience of being so close to the cloud, that was quite a big shock for me, but I really enjoy it, and now I don't like that layer of abstraction anymore because I'm really confident with the cloud. So it's from the pain you learn.
Thanks.
You're welcome.
Okay. One more.
You said testing, automating the tests was
Yes.
very critical for the rapid deployment of the
Yes.
application. So my question is, was it very difficult to set up the testing pipeline correctly when you had so many distinct services?
Well, we were using JavaScript, so we were using, for the unit test, the basic libraries from testing. So we were using Chest and Chai and all those kind of things, so that was pretty easy. And for the integration test, we have our own kind of library to run integration tests. So depending on the type of integration we were testing, we might run different type of tests, but usually we deploy the function, for example, in staging, and if we need it, and we run some integrations tests there. So we have different strategies for different type of problems. So that was very painful to write, and that was also, I think, there is no real solution nowadays on how to do it. So that's one of the biggest gaps in serverless on how to properly write your testing and having an integration strategy. A lot of people do a lot of local testing, trying to try, for example, your database. You download the database thingy and you run it locally, and then but that doesn't work because for example, if you're using Dynamo might change and you might not have the latest version, so you are testing on pointless. So that's why you need to think in each individual case of each function on how to run those tests. And for example, if you're using a third party, you might want to do lag testing. So because when you're using serverless, you might have some kind of big latency. So how that impacts on your third-party requests or responses. So you need to think in each individual case how to write those integration tests, and that was really hard.
And a follow-up question. So, so when you tested services that use third-party services,
Yes.
Was there a lot of mocking involved?
Well, when we write the unit tests, we were only running unit tests that were kind of no internet connection required. So you can run them from your local machine and they run in 2 seconds. So we mock and stop everything, even Dynamo tables that are our database. So we have, because we were not interested in testing that. But when we were doing the integration test, then we want to go to the real thing. So we have, for example, sandbox accounts for different third parties, or we were testing if there were Rovio services, we were testing in the staging environment, to make sure that if their API changes, because sometimes that happens in a big company with lack of communication, that somebody changed something in their API and they don't let you know. So this kind of integration test will help you out in that case, or if you are sending something wrong because somebody's changed something. So there is different levels of testing. For unit tests, totally internet-less, so you need to run them very fast. For integration tests, go against the real thing.
Okay, so and last question.
Sure.
So when you fired up everything locally, like you said,
Excuse me?
when you fire up the entire service locally, how
Yes.
does that work? If you have like multiple functions, did you use some kind of framework?
When you run functions locally, we didn't run. What we run, we build the code in a way that the function layer, like the function environment part, was kind of separated in a way from the business logic. So we unit test the business logic. And then when you're building serverless, you have this handler file in JavaScript that basically was just calling that business logic. So everything was happening in the business logic part. And then the handler part, we can do some small unit tests, but it was kind of pointless. So that kind of separation really helps. So we didn't need to fire up local lambdas or things like that, because that really doesn't make sense, because you want to test your lambdas in your cloud, because when you download things locally, they might not be exactly the same that they are in the cloud.
Okay, thank you for a
You're
great
welcome.
talk.
Okay, thanks, Marcia.